talking about the actual periodic table. Let's begin, guys. Check. I'm not going into super depth, but yes, much of a depth. Okay, so now the periodic table looks something like this. I'm going to go a bit fast with it. Yeah, that's what it looks like. Buildings, a set of buildings. This is called group 1, group 2, group 13, 14, 15, 16, 17 and 18. Start learning with me. Again, a portion, it's of 9th standard, right? But you should know it. We also call it as Roman 1A, Roman 2A, Roman 3A, 4A, 5A, 6A, 7A, and 0. Group 0, we come to it. Out here we have the groups from 3 to 12 or Roman number 1B, B to 7B and 8. That's how it goes. Yeah. Now, first thing, these group A elements, okay, having a quick review, group A elements are called normal elements. So if I talk about group A elements, we call them as normal elements. And group B elements, we call them as transition elements. Now what is the difference between them? Normal elements consist of metals, non-metalloids and non-metals. However, the transition elements out here, they consist of weak metals, only metals a bit weak in nature. Okay, first. Second point, normal elements, this and all of these, the normal elements, only the last shell, okay, the last valence shell is incompletely filled. However, for all these transition elements out here, the last and the second last, that is the valence shell and the penultimate shells are incompletely filled. So these are 2 points of differentiation between normal and transition elements. If I fill the table, guys, yeah, let's say this is going to be your period 1. So period 1, period 2, right? Then we have period 3, period 1, period 2, period 3. We have then period 4, period 5, period 6 and finally period 7. In period 1, you have hydrogen. Hydrogen can also be a part of halogen, 9th standard hydrogen chapter. And we have helium, inert, duplet, stable. Then we have lithium, we have beryllium, we have boron, carbon. Okay, after carbon we have nitrogen, oxygen, fluorine and neon. After neon, we have sodium. Okay, after sodium, come on, magnesium, you know it. Aluminium, silicon, phosphorus, sulfur, chlorine, argon. After argon, we have potassium, K, calcium. Potassium, this is K, and calcium. Right. Calcium is the 20th element. So I can say this is the 20th element and all I need from you all to know is the 20th, up till 20th element. Also, I want you all to know a few more apart from this. We have hydrogen, lithium, sodium, potassium, rubidium, cesium, francium, where francium is radioactive in nature. Out here in the 17th group, I want you to remember a few more. Fluorine, chlorine, bromine, iodine, astatine, and no need to remember this one. So we have krypton, xenon, radon, and you don't need to remember this. So this was about the normal elements and the transition elements which I have written, right? And we have seen the differentiation between both of them. Alright, so these are the elements which I have written on the board, should be by-hearted. Alright, after this, guys, we're going to study about the number of elements. In the first period, we have only 2 elements. Hence we call it as the shortest of the period. We have 8 elements in the second period, 8 in the third period, 18 in the fourth period, 18 in the fifth. Period 6 has 32 elements and period 7 has 26 elements. Now this is a thoda slightly, an antiquated sort of a periodic table. However, even period 7 now has much more elements as what I have written. Alright, so if I talk about the shortest and the size, I've spoken about the numbers. Period 2 and period 3 together, they have the same number of elements. They are said to be short periods. Period 4 and period 5 are stated to be long period. Even period 7 is a long period. And period 6 is the longest of the period. So guys, which is the longest period? It is period 6, consisting of 32 elements. And period 1 is the shortest of the period, consisting of 2 elements. Now, usually kids tell me, sir, there are 18 columns. So obviously, in period 4, there are 18 elements. Period 5, there are 18 elements. Alright. Period 6, sir, are also 18 elements, right? Then how did you write 32? How is it possible? I tell them, nice question. Listen, at the bottom of the series, we have a continuation of period 6 and period 7. So we have period 6, we have period 7, consisting of 14 elements each. So out here guys, in this period, this one, there are 18 elements out here, 18 of them. 18 plus 14 makes it 32. That's how you have 32. In the 7th period, out here, you have 12 elements. 12 and 14 out here makes it 26 elements. That's how we get 32 and 26 as the number. And these two periods or these two rows which are placed separately at the bottom of the periodic table are called inner transition elements. And there is a special name given to it. So can I say the inner transition elements are the two periods, 6 and 7, a continuation. And they consist of lanthanides, which are also called rare earths. And we call the period 7 as actinide, also called it as radioactive elements. Alright, starting from cerium to lutetium or lutetium, my wish. Cerium to lutetium and thorium to lawrencium. This is the start and the end. No one's going to ask you, but just remember it, right? So this was about the inner transition elements, which are also called the radioactive elements, right guys? So all of you all, till now, this was a briefing about the periodic table. Now, if I talk about the first group, down the group, I know that the valence shell configuration remains the same. And we have studied about the significance of a column, of a group, right, with this. Now, always remember one thing, students. If I talk about the first group, the first one, we call it as alkali metals. So, group number 1 are called alkali metals. Group number 2 is said to be alkaline earth metals. These are transition elements. From 13 up till 16, we call them as post-transition elements. 17th group is said to be halogens. And 18th is said to be inert, the zero group. So always remember, students, if I happen to ask you a differentiation between any of these, I'm going to give you a quick pointers. First one, come on. Alkali metals, let's consider sodium as an example. Can I say sodium is a very, very, very active metal? Point number 1. Second, the valency is 1 plus to be more precise. Because sodium gives away one electron. It gives away an electron. It becomes electropositive. It is a reducing agent because it gives a negative power to someone else. So it undergoes oxidation, rise up, right? And so I can talk about the valency, the electropositivity. Then we can talk about a very active metal reducing agent undergoes oxidation. Okay. So these are all the properties of alkali metals and also alkaline earth metals. The same properties. Because they both are metals. If I talk about halogens, the 17th group, they are electronegative because they take away the electron, right? They take away an electron and they become negative. They get reduced. They are oxidizing agents. And the valency is 1 minus. You can say that is the oxidation number, 1 minus for the halogens. Inert gases, on the contrary, right? They have zero valency. Why zero valency? Because they are stable. They don't want to take, share or give or there is no transfer of electrons because they are already stable, right? They have octet or duplet. So they have zero valency. They are not reactive under normal conditions of temperature and pressure. Transition I have already spoken about. Normal I have already spoken about. The post-transition elements, these ones, group 13 to 16, consist of metals, metalloids and non-metals. They consist of everything, every damn thing. The first two consist of metals only. 17th consists of non-metals. So this was all about the generalized concept of non-standard periodic table. Now talking about the periodic properties and the bridge elements, two new things. So first, if I talk about the bridge elements, I give you an example to explain this concept. We usually talk about period number 2 and period number 3 in order to explain this concept. Listen, in period 2, I have lithium starting, lithium. We have beryllium, we have boron, we have carbon, we have nitrogen. Come on, this one. Lithium, beryllium, boron, carbon, nitrogen, oxygen and so on. Just underneath lithium, we have sodium, magnesium, aluminium, silicon, phosphorus, sulfur and so on. Always remember, the bridge elements are those elements which have a diagonal relationship. I'll tell you what do you mean by a diagonal relationship. Now can you see these are all diagonals which I've made. You know what, in a geometry, right, isn't this said to be one of the diagonals? Of course, yes. So what's a diagonal relationship, guys? Remember, if you talk about period 2 and period 3, these elements which are diagonally placed, they show similarity in the chemical properties. Now we very well know that if you go down the subgroup, the chemical properties are similar. That is for sure. It goes without saying. But there are few elements in period 2 and period 3 which show even a similarity in the chemical nature. Hey, lithium, it is like magnesium. Hey, this beryllium is something like aluminium. The properties are very much similar of magnesium with lithium, aluminium with beryllium. Alright, so even there is a diagonal relationship. So if I happen to write in short, in the exam, first I need to draw this and show this representation, and I can say that there is a diagonal relationship. Diagonal relation means what? It means that there is similarity in chemical properties. Diagonally, please. Alright, so this was about the bridge elements. Now, if I talk about the periodicity in properties, we are going to first study about atomic radius. Then we'll be studying about the second property is ionization potential. We'll be studying about electron affinity, electronegativity. And finally, we'll study about the metallic and the non-metallic nature. So now let's study and start with atomic radius as the first periodic property, right? So till now what we have done is the main chapter starts from here. The periodic properties. This was all just a briefing of 9th standard, a quick review of 9th I've done with you. You should know the basics, right? Now remember, while speaking about all these 5 periodic properties, I am going to take an example of the second period. Or let's take example of the third period, this one. And the first column. So I am repeating what I spoke in order to understand, okay, to just, analyze the periodic properties. I am going to take an example of the third period and the first group. And whatever I'm going to speak, that pattern, right, that theme remains the same for all periods and for all groups. Always remember, right? So just go through this, alright? Please, 9th standard, as I said, you need to know it. We jump to the 10th, the atomic radius.